Hey guys, in this series I'll be going over how to create a basic speedometer using Blender geometry nodes. So it's quite simple, but it's highly parameterized. So there's a lot of nodes here, but we also have a lot of control that comes with that. So we can change the length of these ticks here. We can change the maximum speed, so we can change this to cap out at 200 instead of 300. We can change the radius of the whole circle, and we can change the starting angles. So if we change this to 0, it's going to be a full circle, and if we change this to 90, it's going to be on that top hemisphere, and we can change that in between as well. Then we control the number of ticks there are as well on this dial. So let's get into it. I will start a new Blender project here and start a new. So I want to create a cube, which we'll use as my basis for my geometry nodes. I'm going to open a few windows here, one being the spreadsheet, so we can check numbers on here, and then geometry nodes, edit on here, create a new one, and we'll be using both of these. Well, we'll use some input variables as well, so that the user can define and change its variables like we just showed before on the side here. So to create, first we'll start with getting this in top view, deleting the geometry, actually just deleting the vertices. We still want the object. So first thing we want to do is create a circle and then create points along that circle, and then for each point around that circle we're going to create those boxes. So we'll start with that. We'll create a circle which I've chosen. Actually, it won't always be a circle, it's going to be an arc, because often when we change it from the top hemisphere, we want it just to be 180 degrees, and when it's a full circle, we want that to be 360. So it gives us a starting angle, so we can start it wherever we want to. So if you want to start at 30 degrees, we're going to change this to -30, and it's going to start here. And then we also need to calculate what sweep angle it's going to be, so that the end of it's going to be on this side as well. So that's something we'll have to figure out. But for now, I'm just going to change curve to points, and the number of points on this curve is going to be how many of these boxes we're going to extrude out. So we'll keep it as 16 just for now, and we don't need that geometry node just yet. I will. We also need the text in the middle showing the speed, and that's a really easy one. So if we go string to curves, and then we want a map range, and so our time for the animation, we're going to have a time, and we get the scene time in seconds. Scene time in seconds, and we're going to have this go from 0 to 1, climb from 0 to 1, and then go back to 0, and then start climbing again, so that we can control the whole animation between one timer that just goes from 0 to 1, and we can use that time to then dictate max speed and how many of these ticks to show given any time. So first of all, we're going to divide this. This second is a bit too big, so we're just going to divide this by time by 5, sorry. And then we're going to just grab the fractional component of that. So I think it's in math. That's floor. Fractional. Fraction. Don't know why it took me so long, but there we go. So now that it's a fraction, it's going to divide this number by 1, and whatever the remainder is, it's going to give us the fractional component. So this can't go above 1, basically. So we're going to use this in our map range. So we will take that as our value. So we're going to take that value that goes from 0 to 1 and then change it to 0 to the max speed, which we will create a variable for as well. So create this group and change this to max change this to 300 to begin with, and this value will go, so first we need to convert this into a string, so we'll go value to string. You want no decimal points on this one, and plug that straight into there. And then we're going to get some curve instances, and we just want to fill those curves in so that we have a full mesh and not just wireframe. And we can see what that looks like by chucking that in here. So we have the number here. We just need to change where this is centered around. And I think it's middle and bottom left is good. So it's right in the center, and then we can start joining these up so that we show the points and the line. So our points here, I'm just going to create instance on points. Instance on points. And what we're going to put on each of these points is just a cube. So cube mesh. And that's pretty big for now, but we'll change that and we'll make this a variable as well. So now we can change it in here, and not sure which one is which for now, but the next thing we need to do is use this rotation to direct the position, direct the angle of this. So there we go, it's going to face outwards from here. If we can change this around as we need to. So that's pretty good. And we see as we up the count, it gets better, but we're having this issue where it's starting down here. We want to pivot it off, and it's going to start at -30. We can move this to be the center, but we want this fully parametric. So whatever value we bring in, we want to dynamically change this start angle and this sweep angle. And so the best way I found to do that is so math node. I'm going to multiply here. So grab this out and rename this to angle. And this one here is going to be our sweep angle, and I've just calculated this ahead of time, but it took me a while to get there. But if I go 360 minus that, and then I transfer this to radians, and plug that into that sweep angle, and we'll move this all across. So then for our start angle as well, I will do the same thing. So subtract, so 90 minus this number, and we're going to multiply it by -1. As we're going in the negative direction, we want to start down here. We don't want to plus it and start up here. So times it by -1, and then 2 radians again. And that's going to be our start angle, and this angle down here will now change dynamically. So what we'll do is cap this, so 0 to 90, and then you'll see as we go from 0, this is the full circle, and we'll scroll to 90, and that'll give us our hemisphere. There is a bit of weirdness going on. These ones on the side here should be going completely straight. So we can change the number of points. That doesn't quite get us there. So resolution of the arcs, that's going to get us a better result. So bump this up to 200. And there we go. We can change the points down now. Actually, this curve to points will make this a variable as well. So we can change this on the side here. There we go. I'll just change the text size to 0.7. can even parameterize that as well. So if we can drag this across and then change it in the editor here, however we want. Cool. So now we just need animation to this. So what we want is a way to start off with the angle here and then find a number that maps it from a number that goes lower on this vertex and then goes higher up here. So the way we do that is we change these curves to points, but we don't have a position of where these points end up. And if I just create a position node here, this is just going to get the position of the object itself. So the only thing we have to work with is this tangent, but we can use a tan to, let's go separate X, Y, Z. So we're only in the 2D plane at the moment as we're making this, so we only need to deal with, I think it's the X and the Z component is where these two sit, but we'll go math, and A tan2 is a good one for getting the angle of a given vector. So A tan2, plug this in, let me just double check. So it's the Y value. So it's going to give us an angle, and we can plug this to our output to see what that actually is for each of those points. So output attributes, and we'll call this A, and then once we instance those points, we go here, actually curve the points, we'll plug that in, and then we'll look at this point data. So as you can see here, we have an angle that goes from -3 all the way up to 0, which is good, and we can test that by changing the angle to 0. So now that all the points are all around the circle, you'll see that it doesn't go up smoothly. We want this to go from a low number to a high number, but it's wrapping around. So it's going from 1.5 really quickly into the negatives and then back up to 1.5 and wrapping right around. Whereas we want a 0 and then the biggest number. We're going to order it from smallest number to biggest number. So the way I found to do that was to, after we have this A tan, we need to add math. So I'm going to add 3 times pi divided by 2, 4.712, and wrap this around using modulo, and that's going to be 2 pi. Cool, and we can see what that looks like now. So if we chuck this into here, now you'll see that it goes from 0 right up to 2 pi, which is what we want. And now we can use this value to then start making these objects disappear. So now we have angles for each one. We can, when time equals 0, we'll just have objects that have 0 angle, which will be this one, and then we'll increase it and make more appear. So we need some kind of selection to set these from. So before we get those instance on points, this instance on points one has a selection, so we want to create instance on points if it fits some criteria, and the criteria is going to be based on this angle up above. So I will move this actually way over, and we want to say less than or equal to some value. That's going to be our selection, and I just want to map the range of mapping it to here, and then okay, so we use another map range function. So we have a time that goes from 0 to 1, and we want to change that. So 0 to 1. We'll grab our normalized time, which is this fraction here. Plug that in there, and instead of going from 0 to 1, we want this to go from 0 to 2 pi all the way around. So we'll call this 2 times pi. And result is greater than this. This should work now. So there you go. That's working. It's just one little problem is when we change this angle and go back to the start, we should have some ticks here in this range by now, but they're not starting because this starts here, but we need to map that over to there. So instead of this map going from 0 to pi, it needs to start at whatever this angle is and end at whatever this angle is instead. And the way we know that is it's going to be 0 plus whatever our start angle variable is, and then it's going to be 360 minus what that start angle is, or 2 pi minus that start angle. So what I'll do next is bring over that angle, and I go 2 radians and plug that into here, and then I'll go math, and I'll do that 2 pi, and then minus that value and chuck it in here. So now we're at a low value and we get that first tick there, which is what we're looking for. And it wraps, as soon as it gets to 300, it wraps back around, which is good. And then we can change this angle and just make sure that it all works okay. So we're at almost 0. We still have that first tick there. That's all working perfectly. And then from there, you can add materials, do whatever you like, but there's your basis. I'll just chuck this down and increase the size and give it a plate. Perfect, and that's it. Thanks guys for watching. Catch you on the next one.